Hello, I'm Meg Schwarzman, and let's see, I can start by telling you a little bit about sort of what my work is and how I got here. And then, as I understand from Betsy, the reason you wanted me to join is because you're working from the analysis that we did of the toxic VOCs in consumer and commercial products. And so I wanted to hear a little bit from you all about how you're using the information and what you're doing with it and what you'd like to know about it. And then I can talk about, how we did that research and some of the lessons that we drew from it. And I'd love to hear your thoughts about what should be done based on it. So, um, I mean, I have a presentation, but I don't want to just like go through it because I first really want to hear what you all are working on and how you've already engaged with that um, analysis, and we could go from there. So, just to let you know a little bit about my background and kind of how I got to be doing what I'm doing, which is a combination of things. I originally trained as a family physician, actually, going back. I was in college, I was a history major, so I was not pre-med. I didn't think I wanted to be a doctor. And but I was interested in science among other things, but I don't regret for a moment the training that I had as a history major studying history undergrad, um, um, because it taught me a couple key things. One was how to write well, and another was kind of this investigative process that historians do for, like, we had a seminar where we were given a document that, nobody had done any research on, and we were meant to figure out what it was and what role, how to understand it in light of its historical context. Like, I had a letter that was written by a merchant marine on his first trip to Venezuela in the hide trade between the East Coast, like Salem, Massachusetts, and Buenos Aires. And no one had ever studied this document, and I got to like write a history on of like what was this relationship between Massachusetts um, uh, and Buenos Aires based on this letter and the detective work that's involved in using one piece of evidence as insight into a whole cultural context and time in the world, I feel like is like excellent training for all kinds of other inquiries. And I still draw on that and on the writing today. So just to say, a lot of people who think they want to go to medicine feel like they have to be pre-med. And I would say study things that interest you and you will learn from it and be able to use that knowledge in whatever you do. So I then took some prereqs and went to medical school and then did my residency here at UCSF in family and community medicine based at San Francisco General. I thought I wanted to do urban underserved primary care, and that's what that program specialized in. It was my first choice. And a couple years out of residency, I was just feeling incredibly drained and depleted the by doing primary care on a daily basis, especially in a county um, system that was totally under-resourced, where my patients needed so many things that I couldn't give them. And I wanted to help, and I was also burning out. And so I went back and got my master's in public health at UC Berkeley in the environmental health sciences. I had read a book that was really influential to me at the time, and I really recommend. It's called Having Faith, An Ecologist's Journey to Motherhood by Sandra Steingraber. And it is, I was not a parent at the time. I wasn't an ecologist. It's like a title that might not appeal to you, but it's written by an ecologist, Sandra Steingraber, who was learning about um, the science of endocrine disrupting chemicals, and she tells the story through the seasons of her pregnancy, talking about how endocrine disrupting chemicals can change fetal development. and affect future disease because of exposure in the womb. And that was something she was kind of learning about while she was pregnant. And I was like, well, maybe I just want to be an organic farmer. But instead, I went back and got a public health degree in environmental health sciences, thinking I could use my training and work in prevention. I think I was feeling really overwhelmed by, for example, like prescribing inhalers to all the kids with asthma in my practice and not able to do anything about the Superfund site that was next to their school that had a fire like smoldering underground. So I felt like I was sort of throwing medications at the problem without being able to treat the underlying issues, which is why I kind of turned toward public health. And my work has been around toxics since then, but specifically with a solution-oriented approach in the field of green chemistry, which is thinking about how to identify things that are toxic and identify and then design up front safer alternatives. And that's I teach, and that's what my research has been on too. Before I say anything about the research that we did, I would love to hear from you all what you're doing with the, Betsy mentioned that you're using the paper that we published on that research, but I don't know how. And I want you to tell me how you're using it and what you're doing.
Right now, we're still kind of figuring out the exact direction of our research, but for now, we started off by kind of trying to estimate the toxins that certain people of different occupations are exposed to. So, for example, like chefs versus construction workers. And we're trying to get a read of which jobs um, are more have more exposures and trying to kind of see what those populations are.
You gave examples, but I missed one of them. You said something versus construction.
Oh yeah, just an example, but chefs versus construction workers.
I still didn't catch the first one.
Oh, chefs.
Chefs, got it. Okay.
Yes.
Just as an example. Yeah. Okay. Yeah. And how are you going about understanding what product categories people might be using in any particular occupation?
So we're going through kind of I think it was table S4. It kind of has different product categories. And if someone in a certain job, let's say construction workers, would be exposed to those kind of sets of products. Like for example, we have like adhesive removers, then we would kind of include that for that occupation. And we're kind of adding up the emissions.
So you're just thinking through, are you trying to figure out, like you're thinking, well, who would use adhesive removers?
Yeah, well, I for construction workers, that was kind of the group that I was looking at. We all have different occupations that we chose, but I wasn't too familiar with everything that they use, so I asked ChatGPT and asked me to also kind of give me like sources, like proof that they do actually encounter those things, and those were kind of the substances that I was going by.
Thank you for the link, Daisy. Let me just pull up this spreadsheet that you're working with.
So that's a preliminary. We would like to see it because we saw all the toxins, the elements and then all that, but behind that, who is exposed the most and then what is really toxic chemical exposed to the occupational, workers. So that's what we're trying to do. This is kind of random things, but we thought these workers exposed the most. Some
Yeah,
of them are missing, but we choose that, yeah, that occupation that it exposed a lot at their workplace.
great. And are you all working on this or are some of you doing different projects?
Well, we just started working with that. We just exposed, yeah.
But everybody's doing the same, everybody's contributing to the same.
Right, exactly. You can see the name of it.
Yeah, okay. And I see that you're working with total emissions. So it might be worth just thinking through together a little bit about how you would get from a total statewide emissions number to thinking about, like, are you trying to get from that total emissions number individual exposure estimates? Is that the goal? What's your goal?
This spreadsheet you're looking at is very much purely exploratory.
Hmm.
So the direction of research we're trying to go into isn't trying to look for specific products within the categories, but more of we're trying to look at more vulnerable demographics that might be more exposed to like whatever chemical or product category or depends on what we choose to go on with, but we're trying to use this as exploratory material so that we can slowly bring the scope in narrower.
Got it. That's great. So you're not actually trying to like estimate how much a particular occupation might be exposed to. You're looking at which occupations might be coming in contact with particular product categories or particular chemicals and and combinations of them, and therefore which people might be particularly exposed and like to some of the chemicals which are like higher in the emissions, that kind of thing.
Right.
Also looking at we did a we did kind of a prioritization in potency. Is that a piece that you've brought in yet? It's okay if the answer is no.
What exactly is the definition potency
Okay,
here?
I'll talk through that. I'm just kind of like taking
All
notes
right.
for myself about what we should touch on. Anything else that you would add to describe what you're trying to do with this information or the investigations that you're kind of exploring right now? Just to help me understand what you're trying to learn from it, and then I can help steer you.
We didn't really define our themes or direction yet, 100%. Dr. Nosu will come back tomorrow and then we're going to discuss more. But my understanding, my kind of direction, everybody, we just try to see that published research paper and then mostly your research paper. We would like to have a top kind of 5 or 10 most vulnerable occupation, and then their socio-demographic analysis, and then ages and all that, and then how it will state by state or how we're gonna decrease, how we're gonna help, and what is the other the factor characteristic analysis or that kind of things so far that I was thinking.
Great, great.
But
Okay,
other kids will have a different direction and we didn't really discuss yet.
okay. Sure thing. Great. Well, that's helpful for me in helping you all think through it. Maybe I will share screen and present a little bit of kind of um, the the background about the paper in case it helps you. I know it's really dense reading, like it's hard to wade through that research paper for everybody. Not doesn't matter on your level of expertise, depend on your level of expertise. So we could talk through it a little bit and you all could ask questions. I could try to clarify anything that isn't obvious, and we'll go from there. What I do want to say is I really want this to be useful for you. I don't want to just like give a lecture about this paper. So please like unmute once I start sharing my screen, I can't see I can't see you all on my Zoom interface anymore. So please just unmute and speak up if you have a question about anything. Okay? Promise? One thing I wanted to mention is this paper got a ton of press coverage. I did interviews for the New York Times, for CNN, US News and World Report. There was stuff in Washington Post, I think LA Times, because I think one of the things that we put in our press packet about the paper was this figure that over 5,000 tons of, they called it dangerous fumes. I think we said, volatile organic toxics were emitted from consumer and commercial products in the state in 1 year. It was reflecting our analysis of 2014. And that's a pretty striking number. Volatile compounds are not very heavy. right? Like this is like the fumes that come off of, when you open a permanent marker and it smells bad, or glue and it smells bad. That's the vapors that are coming off of that. And it's not very heavy. So 5,000 tons of that a year in California is a lot. Of course, the press really picked up on the consumer product aspect of it, but I'm really glad that you all are pointed toward the occupational impact, the implications of this, because if I use a detergent a couple times a week in doing laundry, that's really different than somebody who works in a hotel or in a linen service that supplies hospitals and is running laundries all the time, all day, every day of their working life. It's a very different scenario. And so I'm really glad that you're looking at the occupational side of it. It's not the one that the press and the public tend to look at as much. So I've asked you this question already, sort of how are you using the information in the paper? Also, if there's anything else what do you want to know about the project? So I already have written down to address the question of potency and help you use that to prioritize. Is there anything else? I understand you're only doing preliminary investigation so far, so you're not experts in this yet, and that's okay. But do you have questions at the outset? Is there something you want to specifically hear about?
This might not be specific, but I was just curious on because while we're looking at, we see some really widespread chemicals, but some other not such common prevalent chemicals, but still part of like one of the top tier priority chemicals. So I was wondering if we were to take the route of trying to like look at I think styrene. I think that was one of the chemicals that we want further investigation into, but it's currently not, but also it seems really widespread. So is that even like a viable way of to like looking into that kind of thing? Or is it even feasible or not? Is
Let
kind
me
of like
see if
what I'm.
let me see if I understand what you're saying. There's the question of like chemicals that are really prevalent, either because they're very high emissions or because they're show up in many different kinds of products, um, or in many different product categories. There's like the really prevalent chemicals, and then there's also, you called them widespread. And then there's also the issue of potency. Like we said, these are kind of high priority because they're highly toxic, and the lower priority because they're less toxic. And that's sort of two different ways of thinking about priorities. Is that what you were getting at?
Yes. I was more so getting at both aspects, but you defined them very well for me.
You were getting at which aspect of that more?
Both.
At both, yeah, yeah.
Yes.
So I think those are both good ways to help prioritize. And um, we looked at this through the lens. I'll go over our methods just to help clarify, but we kind of did the same thing. We sliced the data multiple different ways because each way gives you a different window into the information. So you don't have to have just one way that you're prioritizing. We might have called something lower priority in terms of how potent it is as a toxic chemical. But it might be in the end a high priority because the emissions of it are so great that the impact of it would be really high. So I think you do have to, it's reasonable to take both of those into account, and they just tell you different things. Did you have a question about that, Daisy?
Oh, not that one. I'd like to have one more thing that I want to know.
Yes, tell me.
Okay, so Dr. Sadie, we are talking about radon and cancer and all that. Until then, that I was involved and then learn everything, I didn't know that how toxic products every day. And then we are kind of all result based. Somebody has a breast cancer, somebody has a lung cancer. That we were talking about or trace back. And then what was that? Even though we didn't know. And then yesterday, I have a pest control guy that I was talking, and then he said, "Oh, that I have a one household that dad put it all the lead in the attic, that toxic for the the toxic for the person, and they didn't know, they didn't have any idea. So my question is that all of this, is there any kind of how can I say, education or regulation for the customer, for the consumers? Because we got all these products, we know that we have all this like clean and how fast we can do dishes, but we don't know, we don't have any idea how toxic the chemical is higher and hurt us.
Yeah, it's a great point you raised, Daisy, because the just to say for a second, we can get back to some of this later, but chemicals, I mean, products are marketed on how well they perform, like what job they do. This is a tile cleaner or something, on how well they perform and on how good a value they are, how expensive or inexpensive are they, right? And there is no fourth piece where they're saying this one's safer than the others or this one's more hazardous. And in fact, in some categories of products, sometimes people see high hazard as that means it works well, right? Like you want the warnings on it. If you're looking for something to kill cockroaches or something, you might be drawn to products that say they're toxic because you're like, yeah, I want it to work really well. But what you're getting at is just the legacy of the really ineffectual regulation that we've had of chemicals in products, and in materials, building materials, in textiles, clothing, everything, where there is currently there's nothing that says that chemicals have to be proved safe before they can be used. And that's what has led to this situation. But one thing that there is that was designed as education, in a sense, you asked, is there any sort of policy that does education on this, is Proposition 65, which was started as a right to know law, saying that people need to know when there's a hazardous chemical in a product, or they could be exposed to it from a workplace or something. And that is what we used in this research. So in Prop 65, which is only in California, the state keeps a list of, it's almost 900 at this point, substances that are known to the state to be either carcinogens or reproductive or developmental toxicants. And if your product or your workplace or your environment will expose people to a high enough level of that substance, then you have to post a warning. And that is what we drew on. We drew on that list of 900 substances as our source of toxic chemicals to cross-reference with what the volatile chemicals that are in products in California. So there is one. So you all have seen products or statements that say this product may expose you to a chemical known to the state of California to cause cancer or birth defects, right? Like, so you've all seen that. That's a Prop 65 warning. And in separate research, just as an aside, one thing that we've found is that some companies would rather not warn, and so they change the chemical composition of their products to avoid chemicals on the Prop 65 list so that they don't have to put those warnings on the product. That is a different paper that I could point you to if you're interested in it. Anything else that you all want to know about this research that we did?
I think I read that it wasn't possible to get like product specific chemical, right? And
Yes,
is that still true? Yeah, I figured because
that
so
is true.
detailed.
Yes, and the reason is that the state collects this information from companies, and it's mandatory that the companies report it. But they want the companies, the state is trying to maintain its good relationship with the companies that are selling the products, and they don't want all of that information made public. And so the state doesn't turn over information at the level of individual products. Just that's why they lump them into these product categories that you've been working with, where it's like, it'll be like nail polishes. It's not like L'Oreal, lacquer, right? They're lumped together. Yep. and in categories where there were fewer than three, I think, manufacturers or products, they actually lumped those into larger categories because they felt like there wasn't enough. Okay, so this is something I kind of want to come back to. We'll come back to it as we go along, but I want you to think about it as we're talking about this. And I think you're already probably thinking about it based on your projects, is what actions do you think should be taken based on the information that's in this paper? Because you all are looking at some pieces of it. The state is already doing some things based on our findings in this paper. And I'm curious to think together more about what should be done based on this information. So to review for a minute of the animation in this is a little off, but to review for a sec where we got the data and what we did with it, the California Air Resources Board collects this information on volatile chemicals in products, not just sold in grocery stores to people, but used in workplaces, as you know. And their goal is to reduce the quantity of pollutants that are released from products that contribute to ground level ozone, which is a fancy name for smog. So volatile organic compounds, when they're exposed to sunlight, react in a way and they form ozone, which is smog. And so they're trying to reduce smog formation. But as a result, they have this database of, they survey California manufacturers and they collect information on the ingredients in the products. And I'm putting these little icons with them because it's kind of hard to track through the whole project what's what. And so I'm going to label them with these little icons and try to use that to help you track as we go along. They grouped products into general product categories. So this is going to be used to denote product categories. This is like an ingredient list. So they collected which ingredients are in consumer and commercial products. They grouped the products into general product categories, which was for sort of confidentiality, like you asked about. And they separately generated emission estimates using fate and transport assumptions. So that's kind of fancy language to just say they had this information about which volatile ingredients are in which products. They also had sales data for the state. So the companies told them how many, thousands of tons of windshield wiper fluid they sold in the state. And then they also reported the VOC content of that windshield wiper fluid and the ingredients. So then the California Air Resources Board scientists took that information and looking at, the vapor pressure of the individual chemicals and how the product's used and disposed of, made models to estimate how much of that volatile chemical is emitted from the product. But it's important that they have this sales data because otherwise you wouldn't know what total amounts. So we basically are working with three kinds of information. We're working with ingredient information, product category information, and emissions. And the emissions are estimated by the CARB scientists from the other information that the companies gave them. And you can get the estimates publicly on the CARB website. So we repurpose that data. So they're using it to control ground level ozone formation, but we repurposed it to understand which chemical ingredients and product categories might be particularly, highly contributing to toxic emissions. And we wanted to quantify and identify and quantify the emissions of Prop 65 listed VOCs. And so I just want to say for a sec, there's like 900 plus Prop 65 chemicals. And we only found, in terms of overlap, there were only 33 Prop 65 chemicals on the in this database of VOCs. And the reason is that many Prop 65 chemicals are not volatile. Like lead is not very volatile. Lots of chemicals are not volatile. So this really is just a subset of information. So keep that in mind, that because CARB is trying to reduce ground level ozone formation, they're focused on volatile chemicals. So it's just really a subset of toxics. But it's the reason we're looking at it is because CARB is the only one collecting data that's this complete on the ingredients and the emissions from products. So, and then we wanted to identify risks specific to three groups. One is individual consumers, another is workers, and the general population. And we divided those based on, in a sense, the way you're doing it, looking at the product categories and saying, well, this is something that individual consumers would be exposed to because it's used on the body or in homes routinely. If there's a product category that we felt like was routinely used in workplaces, then we labeled it that way. And the general population exposures we considered based on total emissions. So, Jen, to your point, is this do you care about the ones that are most prevalent, that are released in the highest quantities or used in the greatest number of product categories, or do you care about the ones that are most toxic? And the answer, of course, is yes to all of those. We care about them all, but it can help you sort, like we were thinking of the ones that have the highest emissions overall. Most people in the general population are going to be exposed to them. It's just how we were thinking about it. So we went from these speciation profiles that CARB makes, which is like, here are the VOCs in this product and how it's used and the sales volume, and therefore how much we think might be emitted. Then we identified which of those speciation profiles actually contained any of the 33 Prop 65 listed VOCs. And then we looked based on ingredient data at 16 product categories that we thought were used on the body, 18 product categories that were routinely used in the home, and called those as very likely causing potential consumer exposures. Then we categorized 94 product categories as likely causing occupational exposures, and then looked at the emissions data to say which are the highest emitting, which chemicals are emitted at the highest volumes in the state, and those are going to be potential population exposures. So is this in the paper? It might be in a different format, but this basic table is in the paper. I mean, figure is in the paper. And this is just a summary of those 33 Prop 65 VOCs across the product categories. Do you all know how to read this chart? Because it's a little bit complicated, this figure. Maybe I can talk you through it. Is that okay? Or is that duplicating what you already know? I'll talk you through it. So the chemicals are listed on the vertical axis, and the numbers over here correspond to the number of product categories that this chemical is listed in. So methanol is an individual chemical ingredient, and that's like we're dealing with ingredients in products, and it shows up being reported in 58 different categories of products. Whereas propylene glycol T-butyl ether is only reported in one product category. And then overlaid on this is the information that we added of like top tier versus second tier, which is about potency. So I want to say something for a minute about potency, because this is like a toxicological term that you might not be familiar with, but you know about it. The concept is the same outside of toxicology in our regular lives. So like something like snake venom is a very potent toxin because it only takes a little bit of it to hurt you, whereas alcohol is toxic. Alcohol can kill you, but you have to consume a lot of it for it to kill you. If you consumed that much snake venom, you'd be dead long before you could ever consume, as much volume as it would take to kill you with alcohol. So that's this like potency range. I use the word toxin, and so I want to say here just one small detail where toxin is the term that's used for something of biological origin. So it would be like snake venom is a toxin, endotoxin, like made by bacteria, are toxins, but the larger category is like toxicants or toxic chemicals. And those that would include things of biological origin like snake venom, but it includes all the other chemicals that are either naturally occurring like lead or arsenic or cadmium, or that are made by people. So if you say toxin, you're really referring just to something of biological origin. So a better term is a toxic chemical or toxicant, just as a detail. Okay, so what we did is we tried to decide, because we had all this data and we were like, how do we make sense of this and try to decide what's most important here, like highest priorities for doing something about. And one of the ways that we did that was to try to overlay information about potency of the chemicals on to the other information that we had. Now, every chemical on this list is designated by the state of California as a known carcinogen or developmental or reproductive toxicant. So just to say, none of them are safe. These are all known hazardous chemicals, but some of them can hurt you at smaller doses than others. And those are the ones that we designated as top tier with the darker teal color here. And the paper includes the methods for how we did that. And I don't want to go into that now. If you need to know, you can, it's the details are in the paper, but we basically drew information on from toxicology on chemical potency, relative potency. Any questions about this figure or the ways that I've described it? So then we divided, so one thing that we did when we had our list of products, I just want to back up for 1 sec here. This is the chemicals, right? Shown on the vertical axis here. We don't actually have the product. These are the number of product categories here, but it's not actually naming the product categories. We took the list of all the product categories and then just on the research team, we each separately coded, do we think this is used frequently on the body or in the home? Is this specialty use chemical, product category? Is this going to be an occupationally used product category? And we rated them all separately. And then we put them all together, and where we agreed, we just called it that. And then where we didn't, we talked it through and came to agreement. So that's how we came up with those designations. And that's often how it's done in research when you need to categorize things, is just sort of like by expert opinion and by consensus among the research team. So we did that, and we came up with, a bunch of product categories that are used in the body, and we sorted them by using charts like this. So the left-hand side of this, the vertical axis has the product categories, and the horizontal axis has the chemicals. And so the numbers on the corresponding axes are like formaldehyde is listed in 7 product categories, which if you count it up, this would be 1, 2, 3, 4, 5, 6, 7. And these are the product categories that formaldehyde shows up in: other personal care products, nail coatings, cosmetics, nail care, shampoo, etc. So that's how this works. And then if you're looking at the product categories, you could say, well, how many Prop 65 VOCs are reported in this product category? Well, in nail coatings, there's a total of 5 chemicals reported in that. Not total of 5 chemicals, a total of 5 Prop 65 listed volatile organics. So, and you can see what they are. They're formaldehyde, ethylene glycol, et cetera, to each of the colored boxes. And then we overlaid on that the information with color. These are the more highly potent toxic chemicals, and these are the second tier toxic chemicals. They're all toxic, but which ones are more potent? So I just highlighted these examples just to show you how to read this figure, but not because they're particularly important one way or another, just as examples. Any questions on this?
I'm just curious, why did you guys decide to use like 2 tiers compared to like another number?
Like 3 or 4?
Yeah.
Yeah, I mean, I think because we were just trying to find, are there chemicals that rise to the top in terms of their potency? These are all toxic. And so we were just trying to find, it's such an inexact science, because also you're comparing like reproductive toxicants to carcinogens. And how do you compare potency with different endpoints? Those are different outcomes, different health effects. So there's nothing like if you're looking at greenhouse gases, every substance that acts as a greenhouse gas, you can calculate a CO2 equivalent for it. Like we know the warming potential of a pound of CO2 or a kilogram of CO2. And you can, methane, you can calculate what's the equivalency, the CO2 equivalency of a pound of, or a kilogram of methane. And that's like that's a report of potency. Like methane is a more potent greenhouse gas than CO2. So 1 pound of methane has the same impact on climate change, on global warming as less, I don't know what the number is, less CO2. Sorry, more CO2. You'd need more CO2 to have the same effect as less methane because methane's more potent. Um, that's a much more exact science. It's only like a handful of substances, like, I don't know, fewer than a dozen greenhouse gases. I don't even know how many there are, but there aren't that many. And there's really good science linking exactly how much global warming potential they have. We're talking about, I mean, there are tens of thousands of chemicals in common industrial use in the US and other countries. They have many, many different human health effects, and many of them are not well studied at all. And you can't compare like a carcinogen to a reproductive toxicant. So this is kind of a simple sorting method for a very complex picture. I think we don't have the information to make a finer designation, is really what it comes to.
So pollutancy doesn't matter that sex, man and woman, or small body, and then other, it doesn't matter that this is kind of all to general human being.
It's not that those things don't matter, but we're talking about the characteristic of a chemical. So you might have a more vulnerable person, like a kid might be more vulnerable because they are developing organ systems, but the
But I'm
chemical,
talking about second tier and the top tier.
we're using those to describe the chemicals themselves,
Okay.
not their impact on people. So
Okay. I got it.
arsenic is a very potent poison. It doesn't take very much arsenic to kill a person.
I
If
see.
you're trying to kill someone with alcohol, you have to use a lot of it. And that's
Mhm.
all we're talking about.
Okay,
In
thank you.
terms of the potency issue, this top tier, second tier, and top tier. That's we're not saying that the other chemicals aren't important. It's just one way to say like which ones are particularly potent among these chemicals. And partly that came about, one of the reasons we did that is because methanol, as you saw from the previous slide, from this one, methanol is in 58 different product categories. It's everywhere, but it's actually not a very potent toxic chemical. So we didn't want people to look at this research and say they're yelling and making a big deal about something that's not all that hazardous. So it's partly a strategic thing of like wanting to make sure that we're calling attention to things. Everybody knows formaldehyde is really toxic. And we wanted to sort it a little bit in that way so that we could start to make sense of priorities. So then we did the same thing, took our ingredient information in product categories and said, okay, routinely used in the home, like applied to the body, are going to be particularly high exposures for consumers. This is our little pictogram for consumers. So again, this is the list of product categories that we thought were routinely used in the home. And these are the chemicals, the volatile toxics that are reported in those, and how many product categories they're used in. And then, as you all know, we did the same thing for product categories that we thought were commonly used in workplaces. And it's telling to me that this is a much longer list, that the main people who are affected by using sort of chemically intensive products are often workers. And so, like, I think you mentioned adhesives. You want to think creatively when you're thinking about the work types that use adhesives. For example, like well, Teslas specifically, but I think a lot of cars, Teslas are basically plastic parts glued together. There's a huge quantity of adhesives used in car manufacturing. So it wouldn't just be construction. There's a lot of other places, and I'm glad you're looking around and trying to figure out which occupations might use which types of products. Okay, so you're already familiar with this information. We drew out some priorities, and this was based on, so you were talking about like, how do we prioritize based on something's very common or something's very potent? And we just did it every which way we could and pulled out priorities that we thought were important. We highlighted 11 different chemicals because they were prevalent in so many different products. So this is based on ingredient information. And DEA is something that occurs in 40 different product categories or is reported in 40 different product categories. It's prohibited in cosmetics in the EU. It's a when combined with other chemicals in products, it releases formaldehyde and other materials that are carcinogenic. So we highlighted these chemicals because they showed up in so many different product categories. Tell me what you think. I'm going to skip to one place where I wrote this out. What do you conclude from the fact that, for example, many different product categories included or a product category includes multiple toxicants. So this is looking at it the other way. Hang on a sec. Let's stop that for 1 sec. I'm going to go back to this. I don't want to confuse you. I'm going to go back to this and we'll get to that. So we highlighted 11 chemicals because they showed up in so many different product categories. And then we sliced it the other way and looked at the product categories and highlighted those that had many different Prop 65 toxics in them, VOCs. So for example, like adhesives contain 17 different. So do you understand that we're slicing it in 2 different ways? This way we're starting with the product category and saying how many different chemicals were reported in that category. And in the last one, we were starting with a chemical and saying how many different products did that show up in, was that reported in? 2 different ways of looking at the same data. And we divided these, of course, into those that were commonly used in the workplace, on the body, or in the home. And I can send you these slides so that you have our list. These show up in the paper too, but it might be easier just to get them from the list that I have in the slides. And I've just included like these top 4, but there's more, of course, in the supplemental information for the paper. Okay, so that's working from ingredient information and product category information. I separate that from the emissions information, which I denote with these like little bubbles, gas bubbles coming up. And this is a zoom in, I'm sorry, that does make it hard to read, of a subset of kind of the lower left corner of our heat map of the emissions data. So now we're looking at the estimates that CARB made based on the speciation categories, on the ingredient information and how the amount that was sold in the state, and then estimating how much of a chemical is emitted in the state from all the different product categories. So they look at it in 2 ways, like these are the product categories, how many chemicals do they emit and in what volumes? And then also these are the chemicals and how much are they emitted from which products. And then we just drew this pink line here because we divided, these are chemicals to the left of the line are ones that we have categorized as top tier for potency, and chemicals to the right of the line are those that are lower, second tier for in terms of how potent they are. You can see methanol is in this, that'll always be your clue that it's the lower potency group. And so anywhere closer to the lower left corner of this is going to be the higher emission, highest emitting product categories and highest emitted chemicals. Any questions about this? I know you were already working with the emissions data. I saw that color in your from this heat map in your document that you were putting together. But any questions about this? So from that emissions data, we pulled out some of the worst actors, and this is what we highlighted in our graphical abstract, which I drew, by the way. I had to do each of these individual drawings in a program. It took me a really long time. But anyway, because they require you to do original art for the graphical abstract. You can't take clip art from somewhere else. Okay, so that aside, we used that information to identify, 3 product categories that were some of the highest that sorry, some of the product categories that emitted the highest quantities of these 3 compounds. Methylene chloride, which is in paint stripper, styrene, which is emitted from both of these vehicle care products and caulking compounds, and then dichlorobenzene. Wait, I got something about that wrong, which I think dichlorobenzene would be this in mothballs. And I probably left off one here. Sorry about that. But in any case, we drew out these priorities based on the emissions data. Okay, so here's the question that I wanted to pose to you. We sliced the data from many different ways, and I know it can get confusing. So I think it helps to step back and think for a sec about, like, what do you conclude from the fact that some product categories included many toxicants? So for example, the category other adhesives contains 17 different Prop 65 listed VOCs. And I think this you've already gotten at. This is not a trick question. It might be obvious to you. I think you've already started to get at this in your work. But what does this mean for us, for people, that there are these product categories with many different toxic VOCs in them? What's the significance for that for somebody who uses adhesives?
So we can identify based on that graph or the way you draw, and then we can really see define the vulnerable workers or workplaces.
Yeah,
So
yeah.
like other adhesive is like constructor people, something.
I would say that's true. And what I'm getting at is maybe it's too obvious. It's even more general than that. So maybe it's too obvious for you all to say, but just the point is that there is potential for co-exposure to multiple hazardous chemicals from a single product category. So someone might think, well, I don't use many different types of products in my work. I only use adhesives. But just from using adhesives, they may potentially be exposed to 17 different toxic VOCs. So that's one way of looking at the data. The other way of looking at it is some chemicals. So that was starting with the product categories, but some chemicals appeared in many different product categories. For example, diethanolamine was listed in 40 different product categories. So what's kind of a parallel conclusion from that finding in the data?
You can still get exposed to it from other things.
Exactly, exactly. And we would call that aggregate exposure. So there's potential for aggregate exposure to a single chemical from multiple different sources. The fact that it shows up in 40 different product categories means, we use shampoo, conditioner, face wash, I don't know, whatever, all laundry detergent, across all these different categories. So even if each one only exposes us to a tiny amount, we may likely be exposed to very, very significant amounts of the chemical because it's coming from multiple different sources. And that's important because of how to get back to Daisy's question about, like, isn't there any policy about this? It's an important thing to know because we tend to regulate chemicals and products individually. We'll say, like, this one chemical we're going to regulate, like bisphenol A, we're going to, put limits on the use of bisphenol A. But that may only be one of the chemicals that we're being exposed to from some product category. Or we'll say, we're going to look at exposure to flame retardants from foam baby products. But actually, flame retardants are in maybe like tens of different product categories. So to me, these data really highlight the fact that we can't regulate chemicals one at a time or products one at a time in absence of understanding of where all our exposures come from, the many different places our exposures come from. And if we think like, oh, this one doesn't expose us to enough to be harmful, we need to be looking at all the product categories. We need to be looking at all of the chemicals before we conclude that that's not harmful. Other implications, occupational exposures may further expose workers to chemicals that they're already exposed to as individual consumers. So like workers are also, you know, cleaning their bodies, using laundry detergent at home and all of that. And risks from the exposures are not equally distributed in the general population. There's some products, for example, like beauty products that are primarily marketed to women of color that often contain, there's separate research on this, much higher levels of certain toxic chemicals. So there's not a just and equal distribution of these exposures. And then also as a reminder, because of the data source, we only looked at highly volatile toxic chemicals in consumer products because that's all CARB collects data on. And we know that there were only 33 Prop 65 chemicals that were in that CARB database because they were volatile. The other 970 toxics that are listed by Prop 65 that are not volatile may also be in these products, but they're not in this database. So it's a bit of a like tip of the iceberg situation. What else do you think, anything that you want to bring up at this point? Because we're just about out of time, but I'm available for questions. Anything that you want to bring up, questions that you have about the data or how you're going to use it, or other things that you think we should be doing like as a society with this kind of information? Any thoughts you have about it?
Is there any, FDA, Food and Drug, or is there any the consumer products to check everything? This is too much. This is too. Is there anything like a Food and Drug is the same kind of
Consumer
institution?
products? No.
Then what can we do as a consumer?
You know, there are things that we can do as individuals to help reduce our exposure. My first go-to is to eliminate fragrance. So anything that has fragrance has the fragrance chemicals, and it's also going to have phthalates, which fix the fragrance to the product and slow its release. You know that those fragrances are volatile because you can smell them. If they weren't volatile, you wouldn't be able to smell them. So that means not using air fresheners or fragranced laundry detergents or dryer sheets or any of the home care or personal care that you can get without fragrance is going to reduce your exposure to toxics. So some of that you can do by personal choice. I also I try to buy almost exclusively organically grown produce and products where I can. That actually is much less about reducing my or my family's exposure to toxics as it is about, I don't want to contribute to a system of production and consumption that is poisoning the workers in the fields or the kids who are going to school in the, around fields that are sprayed with pesticides. So that feels like my way of contributing, not so much reducing my kid's exposure from the apples he eats, although probably that's good too. But really it's about like, I don't want to be poisoning someone else's kids who happen to live near the agricultural fields. So there are some choices like that we can make. And then the other is there are activist groups that are working hard on chemical policy reform and have been really effective. There's a web tool that I wanted to make sure you all are aware of about who is in which occupations in the state of California. Have you all encountered that yet? Let me send it to Daisy with the slides because I don't want to take the time right now to put my fingers on it. But I'll send it to you because somebody was paid by the same granting organization that supported this research to develop a whole like data visualization system that you can access online that shows which workers are in which kind of occupations in California. And I know that that's very California centric, but because this research is also, the emissions are in California, it kind of makes sense for you all to use it. California is the fifth largest economy in the world. So we're like our own country, and it's okay to use that as a window into, you know, what's being done in the world. So I will send you, along with a copy of these slides, I will send you the that a link to that website where you can do all that data visualization. The one other resource that I wanted to mention is EPA has a website, web-based data source that's called CPDAT, Consumer Products Database, CPDAT. And you can get, you know, it's another way of seeing ingredient information for individual products. There's no efficient way at this moment to take that data and like cross it with our product categories and get more ingredient information. But if you all end up focusing on some particular product category and you want to look at some individual products that are in those categories, that might be a useful resource. I don't think there's anything that you can do systematically with the data at this moment about it. But you can get more product specific ingredient information from that data source.
This is not exactly related to the research, but before when you were showing us kind of like news articles that came out after your paper was published, like how does the news usually get a hold of that, I guess?
Yeah, so we cultivated it. Our organization, so I work for UC Berkeley, and I did this research with Silent Spring Institute, which is a nonprofit science research organization in Massachusetts. And we both have press offices. So before, you know, the paper, we set a date when the paper was going to be released. And we put together a press release with the key findings from the paper in it. And the press offices distribute that press release and an embargoed copy of the paper to journalists. So they have lists of like trusted environmental journalists who they communicate with, but there's also like it's called Eureka. I don't know what it is. It's like a list server or something that journalists use where kind of headlines get pushed out, and all the journalists know not to they know to respect the embargo. So there's a date where the paper is going to be released, and they can write their story, and they can read our article before it's released to the public, so they can write their story. And then that's how, when you read a news article that says in research published today, it's because they were given the article a few days before, and they got to read it and talk to the researchers and write their story about it, and read our press release. So some news outlets just published our press release basically, but things like the New York Times, their reporter reads our paper, reads our press release, does interviews with us, does interviews with people who weren't involved with the research, not just like the researchers on the paper, and they write their own story about it.
That's very cool. Thank you.
So if you have fun, do you have like a time? What is the next? If you know, what do you want to know after this research? What do you, if you want to do the further investigation, what do you want to do?
Well, I'm not continuing this research because of a whole variety of reasons, including that it was part of a grant that ended. But the thing that's really interesting to me about this is the uses that this data can be put to. So, for example, Cal-OSHA, the California Occupational Safety Health Administration, is looking at the prioritization, you know, at our figures and saying, like you are, which occupations might be highly exposed, and do we need to be taking action on some of these exposures? So are you all familiar with the concept of a PEL, a permissible exposure limit?
Mhm.
It's a number that is set for how much of a chemical a worker can be exposed to, with the idea that you can set a limit that keeps workers safe. Unfortunately, that's not how PELs have been set. there's like a health-based Pell you could imagine setting, which is like how much would it be safe to be exposed to for an 8-hour day, 5 days a week for a career. But unfortunately, that information has that number has then typically been essentially sort of diluted by the employer saying what's realistic. So like, well, we can't get exposures that low, so you can't set the Pell that low. So workers, can even, it is sometimes permissible exposure limits are set at levels that are known to cause disease, but it's what the employer has said they can realistically achieve, which is not my idea of how workers should be protected. But in California, what Cal OSHA is starting to do is to revise those pills to have them be health-based. And that's a long process because there's a lot of chemicals to do that for. And one of the things they're looking at is, could they use our data to prioritize which chemicals they should lower the pills for first, and create new health-based pills based on maybe, the number of workers who would be exposed to this chemical or the variety of product categories that this chemical might come from, that kind of thing. The high level of emissions that we reported, that kind of thing. So there's lots of ways. Also, California EPA has a Safer Consumer Products program, and they're using our research to say, are there particular combinations of chemicals and products that we should be targeting? And through their program, they ask producers to identify safer alternatives. So are there, particular priorities that rise to the top here? So that's what I've been doing more, not like doing the next research question, but talking with folks who can use the information to do policy decisions and interventions that might help change the situation. And like what you all are doing, that's super exciting. It's really cool to look at the data and say, like, are there particularly vulnerable populations of workers that we should be protecting based on this? And
Yeah, I have one more.
Yeah.
You said individually you would like to buy organic and all that. That's the expensive one. Organic nowadays is very expensive. So that's why I just drawn to that socioeconomy lower the popularity. They don't have any tools to buy organic products and then all that. So do they have any intervention for the underprivileged or underserved community?
Well, as I said about like buying organic, it's less about how much I think that might be reducing our own personal exposure to pesticides than it is about reducing the use of and demand for pesticides overall. So some of that, those of us with means can help create a demand for, lower the demand for toxics that to which people without means are exposed predominantly. So, but there's also campaigns about like dollar store products, because often the more toxic products get kind of dumped, especially as there's regulation coming down the line. They'll dump the toxic products that they're not going to be able to sell pretty soon into dollar stores. So there's a whole advocacy organization that's working on getting dollar stores to clean up their products, because those are often, put in places and targeting people with lower socioeconomic status. So there is a lot of work on trying to identify the most vulnerable populations and those who can't make the choices with their dollars that they would like to be able to make, and reduce the toxics more equitably that they might be exposed to.
Just going off of that, so if there had been advocates for like, because I was also looking into like lower socioeconomic demographics in dollar stores, and I just knew from the news like they tend to get the brunt of the toxic chemicals. But like, is there? I guess I could look into it, or do you possibly know if there has been research saying that that's like that they do end up expecting more toxic chemicals in such stores, or is this just
I think there is some research on that. One thing that you could look at is Mind the Store. the Mind the Store campaign does some product testing. So they've done some things around like Halloween products that get, dumped in cheap dollar stores or other outlets. See what they're doing in it. They have a bunch of different things they work on, but the Mind the Store campaign is an interesting place to start. And that
Alright,
involves some like product testing that they've done.
thank you. I also had a different question. So
Yeah.
I think the total emission data from supporting figure 4 was just like all the emissions combined. And like, is there a way to slice that it further into like consumer product categories or like that, or is it just assumed that the product categories already have been categorized into consumers, workers, and general population? So
Do you have the supplemental information open in front of you?
yes,
Can you share your screen just because I don't have it right in front of me?
yes. Let me make this bigger.
And
There.
I'm going to try to move this window over to my bigger monitor. Right, so this is the heat map of emissions.
Mm-hmm.
What you can do is you would have to cross-reference, but the information is in the paper. So what you're asking is the product categories are on the left-hand side, and how would you know which categories those are in? Like, are in those occupational exposures or routinely used on the body or in the home? Is that what you're asking?
No, I know it is further like into that, but like I guess maybe I should reword the question into or so once the product categories are placed into their respective categories, like consumer work or general population, is like I figured there would be overlap, but is there no overlap? Are those
There
like
is overlap, but those categorizations were just for our purposes to try to we had to find ways to talk about the data, right? Like you can't just show a big heat map like this, because people go like, well, what's important? Like what should we know about this? What rises to the top? What's the biggest threat, right? So we just had to find ways to sort through and have ways to answer that question of like what's important here. And that's why we sorted the product categories into those designations of like routinely used in the home or on the body. And there was overlap, but um, that doesn't have a lot of bearing on this emissions heat map because the emissions heat map is for the total in the database, right? It's not like divided by category like occupational
hmm
use or, you know, use in the home. Does that get at what you're asking?
yes, in the sense that I realized the total emissions data can't be sliced further into like because again like the designations were
Oh,
done
you're
here
asking like,
to
could we know what portion of these are used in workplaces versus what portion are used by individual consumers in the home?
yes.
Yeah, we have no way of knowing that.
Yeah, okay. Now I've
I
kind of
get your question
figured.
now. I understand your question now. Those data aren't reported. So what the manufacturers tell CARB is sales volume in the state, but we don't know who they sold them to.
Yes, okay. Thank
That's
you.
a good question. I'm sorry it took me so long to understand it.
No, no, it's okay. It's a bit of a jumble when I speak, so I might have one more.
Go ahead, go ahead.
It's just the same supporting document. Well, so I think you might have mentioned, but still kind of went over my head a little. What were the top and right margins representing? Because
Oh,
they're both different numbers, but
on that heat map,
yes.
do you mind putting it up
Yes.
again? So this is sorry, I'm saying this because I'm showing with my cursor, but you obviously can't see that. The top margin, that's the horizontal line across the top where there are numbers, is the total tons per day of emissions of the chemical in that column. And then the numbers on the vertical right-hand axis are the tons per day of emissions of all the chemicals in that product category.
Is it
In
then
that,
how do these come together to create the colors?
right.
Or maybe that's just a complicated like can of worms.
No, I don't think it is. I didn't do the math, but I think that's behind this. But conceptually, um, the higher it is, the lighter the color. So, a product category that emits the most will be those yellow to greens to turquoises, and they're at the bottom, we sorted the grid, so they're at the bottom. And the chemicals that are emitted in the total highest quantities in these columns, the left-hand side, the highest emissions. So let's look at what's this first, what's that first column? Methylene chloride. So it is emitted from these different product categories like paint removers or strippers, pipe cements and primers, sealants and caulks, right? So those, anywhere there's a colored bar, that's a product category that emits methylene chloride. The color of the bar corresponds to the quantity of the emission. And there's the key that shows you, right? The yellower green turquoise to blue. The higher the emission, the yellower it is.
Yes.
And if you want to see the totals, you scroll, if you want to see the total emission for a particular product category, you scroll to the right and look in that row and you see the number that's the total toxic VOC emission for that product category. And if you want to see the total amount of methylene chloride that's emitted across all these product categories, you scroll to the top of that column, and that's the total the total methylene chloride that's emitted across all product categories.
Okay. Okay. I think it's slowly making sense. And then there's one last one. So, but sounds like then these collective shades don't equal to 100%. It's just, it's all different or,
That's right. You're
all
right.
right.
Because you could look at it from, you know, separately. The product categories will all add up to the total, and the chemicals will all add up to the total. But if you totaled the product categories and the chemicals, you would be doubling it.
Okay. All right.
Nothing
Thank
here
you.
is percent, though. There's no percents here, right? It's all just
Right.
it's raw numbers. Okay, good.
Yes.
Yeah,
Thank
I
you.
think
That's
you understand. And if you have follow-up questions about the data, talk to Betsy, but you can email me questions.
Great.
Thank you.
Thank you so much. Thank you. We'll definitely do that. I have a tons of questions, so I will send you an email.
Okay, great. I'm so glad you're doing this project. I look forward to seeing what you come up with.
Great. Thank you.
Take care. Have a
We'll
good
see you later.
Thank you,
Bye.
Dr.
you.
Forsman.
Bye.
So I'm just gonna go through this quickly. I know we kind of have, I think most of us have a bit of experience writing a research paper, but I'm just gonna go through some of the important points. So for the abstract, we generally write this last after we've done everything. And so it's just like a general summary of kind of the little bit about the background and then our methods and our findings. Usually we don't do like a discussion or an evaluation of the work, and it's very factual. And it's pretty short, around 250 words. And I think for most of the APHA submissions are also 250 words, but it kind of depends on the category that you're submitting your paper or your abstract to. And then you have the introduction, which generally you start broad and then you kind of narrow down to your topic. And I'm sure you guys saw in the Dr. Schwartzman's paper kind of how they did it. This is where you put in a lot of the stuff that you gathered from your literature review, just to see kind of what research is already out there and any adjacent kind of research. So for instance, if for the paper that we presented or research that we presented last year at APHA, it was about injury rates in child youth workers. So the introduction would probably start with something more broad, like prevalence of child labor or something, and then eventually narrow down to injury rates. And the introduction is also where you kind of introduce your research direction, and then you move on to the methods. Our methods will be a little bit more straightforward because we're not working with like actual people, we're working with data, but you just want to be as detailed as you can so that someone else can replicate it. That's kind of the whole point of the method section. And I think what's actually very helpful is to try to kind of create a scaffolding of the method section as you start your research. So maybe we could do something like just have a methods document and have a list of bullet points of the analyses we're doing, the sources that we're using, just so later it's easier and you don't kind of have to hunt down like, oh no, what did I do after this? Because after some time you might kind of forget and it might be a little fuzzy. So just having like an outline of that as you do your research will be helpful. Yeah, after that, there's the results section. This is where we're just presenting our research objectively. Like, let's say researchers found that the rate of ADHD has gone up in high schoolers or something. That's like pretty much all you would say. You wouldn't kind of speculate on why that's the case, or if it's consistent with existing data or anything like that. You're just presenting the facts as they are. And if it's easier to explain something in a table or a chart, then it's useful to use figures instead of writing everything out. That'll be easier for you and also for the reader. And in that case, you would just create your figure and then kind of touch on the important parts of it. You don't have to like go through everything in writing. So yeah, just try to keep it concise and try to keep it easy to read because you want it to be as accessible to a wide audience as possible. So just keeping your language concise, keeping it simple. And then lastly, we have our discussion section. So this is where you restate your key findings that you had from the results section, and then you can now interpret like, what does this actually mean? What kind of implications does this have? Is this aligned with kind of what you expected? Is it aligned with other research that you found? Or certain actions that maybe should be taken, and then future directions for where this research might go. But I do know, because of kind of the newer restrictions on research, researchers are trying to be very, very factual and not too interpretive because of Trump. So I don't know exactly how we're going to handle that, but that'll be a Dr. Noth question. But yeah, I think that's pretty straightforward. Does anyone have any questions, especially if you don't have experience writing a research paper? If not, I think we can wrap up there.
So I would like to add how we're gonna write abstract and the research paper. We're gonna divide it, as I told you, the instruction part, somebody who wants to research, explore already published, research or article. That's what we said, literature review. So all the paper already published relate with it or connected or beneficial to our research. And that's the introduction group. And then what methods, and the data, because you kind of a data analysis is a method and the result in between. And then we're gonna all together write a result, and then discussion and limitation, conclusion, we're gonna all together talk about it. We're gonna edit everything. So that's how it goes to all for the core co-author and also group research. Yeah, so abstract, what we're gonna do, all, one or two people are leading, of course, but we kind of chip it in and then edit it. Previously, we heavily, that one or very few people, one or two people wrote it 100% for abstract, but if we can chip in all together, that would be best. And the Dr. knows edit it. And then we edit it. And also Dr. knows that, why don't you do this much again? That this is a little bit weak. Let's add it another co-reference, co-analysis factor, then we kind of put it in there. Okay, so then don't, please come tomorrow, and the Dr. knows. And then after today's Megan's Dr. Schwartzman's slides, that I have something that I have a different directions. So if you have some directions you would like to explore, or you would like to put it in some table about themes that exactly what you want to, please think about it and let's talk about tomorrow. And Dr. knows, so we're gonna start at 7.